So here in this problem, we need to determine the equation of a line such that its perpendicular distance from the origin is 5 units and it has got a slope of -1. Okay, let us begin. So first what we'll do, we're going to consider the equation of the straight line. We will consider here the slope-intercept form of a line. So let y equals to mx plus c, so that is the slope-intercept form of a line, be the equation of the straight line, where m is the slope of the line and c is the y-intercept. In essence, what we have here is y equals to -1 times x plus c. That's because the slope m that's given as -1 in our case. Now let's rearrange the terms. What we get here is x plus y minus c equals to 0. We're going to label this as number 1. So what we have done here is we have considered the general form of the line. Now once we have the general form, what we'll do, we will try to convert it to the normal form. So let's quickly go to the normal form of a line. So that means if we have a straight line with the equation ax plus by plus c equals to 0, then the normal form of the line is going to be given by -ax divided by the square root of a squared plus b squared. And then by is going to get replaced with -by over the square root of a squared plus b squared. Then we have -c divided by square root of a squared plus b squared equals to 0. So this is going to be referred to as the normal form of the line. Okay, so here in our case, what we have here, so we have here a, so a here corresponds to 1, b corresponds to 1 as well, and here c value, that's equals to -c in lowercase. So that means if we take the square root of a squared plus b squared, that is going to be equals to square root of 2. Okay, so what we'll do, we'll now convert equation 1 to the normal form. So equation 1 now becomes, so in place of x, in place of 1 times x, well, what we have, we'll have -a, so -1 divided by square root of a squared plus b squared, so we get square root of 2 multiplied to x. Then in place of 1 times y, that means in place of b times y, we're going to replace it with -1 divided by square root of 2 times y. And then what we have here is -c. So -c is going to become negative of -c in lowercase divided by square root of 2. That's going to be equals to 0. Okay, so let's simplify it from here. So we have 1 over square root of 2 times x minus 1 over square root of 2 whole multiplied to y. So this becomes equals to -c over square root of 2. Let's multiply throughout with -1. So we get 1 over square root of 2 times x added to 1 over square root of 2 times y equals to c over square root of 2. So what we have done, we have successfully converted the given equation into the normal form of the line. However, if we compare it with the actual formula for the normal form of the line, what we have is cosine of alpha times x added to sine of alpha times y. That is going to be equals to the perpendicular distance of the line from the origin. Now clearly cosine of alpha and sine of alpha, that's equals to 1 over square root of 2. So here we have cosine of alpha equals to sine of angle alpha, and both of them are giving us value 1 over square root of 2, which implies that alpha must be equals to 45 degree. And then we have the perpendicular distance p, so that comes out to be c over square root of 2. And we know that is always a positive value, so we have absolute value of c over square root of 2. But coming to the problem, it's already given that the perpendicular distance from the origin is 5 units. So that is given to us, but p equals to 5 units, which means that absolute value of c over square root of 2, so that must be equals to 5. So solving for c, we'll get absolute value of c equals to 5 times square root of 2 units. So that is the value of c. So we now have the equation of the straight line. We considered it to be y equals to mx plus c. M is already given as -1, so c we have obtained it just now. So we can say thus y equals to -m times x plus 5 times square root of 2 is the equation. This is the required equation of the straight line.